Good day, viewers. You are welcome back to my channel. As you already know, my name is Israel Boy. Today, we are going to be talking about one of the laws in gas. One of the gas laws. The law we are going to talk about today is Graham's law. Graham's law of gaseous diffusion. Graham's law. So, Graham's law of gaseous diffusion. What does it state? Graham's law of gaseous diffusion, just like the other laws, apart from the Lewis law, we talk about the chemical property of gases. Graham's law talks about the physical property of gases. The law states that the rate of diffusion of any gas, is inversely proportional to the square root of its density. Let's say this density. This is how it goes. But here we are not going to apply the relation. We just go straight to calculation. You remember we said the rate of diffusion of any gas is inversely proportional to the square root of its density. So let's carry out some calculations. For example, 60 cm cube of a gas diffused through a porous, that's an opening, partition in 226 seconds under the same condition. 60 cm cube of hydrogen diffused in 40 seconds. Calculate the relative molecular mass of the gas. You see it. Now, there are so many formulas you can use. The notable formulas that is applicable to this topic, they are usually three. I call them as three. First of all, you have, let me write it this way, say solution. You have rate of diffusion, R1 over R2 equals square root of D2 over D1. This rate is equals to this density. Then this one, the second one is R1 over R2 equals square root of relative molecular mass of gas 2 over relative molecular mass of gas 1. Then finally, rate equals volume over time. Have this, you can solve all questions that comes out of this topic. So let's see how this one goes. These are the three basic formula. This is the third formula. Have this one in your memory. All the calculations are gone. 60 cm cube of a gas diffused through a porous partition in 220 seconds. Remember, this volume, this time. So you said of a gas A. Let's put it in capital. So you said let rate of diffusion of gas A equals, let the rate of diffusion of gas A equals RA. Under the same condition, 60 cm cube of hydrogen diffused, let the rate of diffusion of hydrogen equals ROH2. You say bed rate equals volume over time. Therefore, ROA equals volume over time, which is 60 cm cube of gas A, 60 over diffused to a point in 2 hours 22 seconds, 226. Then ROH2 equals volume again over time. And we know that under the same condition, 60 cm cube of hydrogen becomes 60 over rate of time, 40, time is 40. Then ROA over ROH2 will be 60 over 226, everything over 60 over 226, which gives you 60 over 226 times 226 over 60. No, to invert. 60 cancel 60. Sorry, over 40. 60 cancel, it now gives 40 over 226. So we have that one first. Now the question says calculate the relative molecular mass of the gas. So remember we already have ROA, A is the unknown gas, over ROH2 equals 40 over 226. And we know that rate ROA over ROH2 equals square root of, remember this formula, I said if we are dealing with density, use it. Here we are dealing with relative molecular mass. Relative molecular mass of hydrogen to go up, this one go up, this one goes down, over relative molecular mass of gas A. So that is how it goes. But we already know that this one is equivalent to this, so it now becomes 40 over 226 equals square root of relative molecular mass of, we know hydrogen is 1 times 2 over relative molecular mass of A. Let's say we are using this place. Okay, they now have 40 over 226 equals square root of 2 over square root of, okay, let's use it together, becomes square root of 2 over relative molecular mass of A. Square both sides, becomes 40 over 226 equals 2 over relative molecular mass of A. Cross multiply, this one becomes square anyway, so it now becomes relative molecular mass of A, cross this way. Let's just multiply it first and see what we have. Okay, let's multiply it so that we don't skip any steps, so that you'll be able to understand it properly. 20 now, 40 divided by 226 will give you square, will give you 0.0313, approximately become 0.0313 here equals 2 over relative molecular mass of A. Therefore, relative molecular mass of A times 0.0313 equals 2. That is how it goes, equals 2. Then you now divide 2. Let me clean this way so that, let me just clean up for better view, because we always consider the question. So you now have, therefore, relative molecular mass of A equals 2 over 0.313. 0.313. Let's see what we have. 0.0313. See now, I have to be very careful. So 2 divide 0.0313 will give you 63.8, become 63.89, approximately 64. So that's what you have as relative molecular mass of the gas. So the nearest whole number